In this video, we're going to learn how to solve rational inequalities. So in our first example, 8 over x plus 5 is less than or equal to 4. We're going to solve this inequality just like we've been doing for our rational equations, which our first step we need to do is find our LCD. Our LCD is going to be x plus 5. So we multiply our LCD by everything in our inequality. And by doing this, the x plus 5's on this side cancel. So I'm left with 8 is less than or equal to 4x plus 20. Subtract 20 to both sides, we'll have negative 12 less than or equal to 4x. And then negative 3 is less than or equal to x. Okay, so basically this is saying that we have negative 3 as a value on our number line, which we're going to test that in a second. So negative 3. Our other value for our number line is going to come from our denominator, which we have is x plus 5. So we take x plus 5, of course, set that equal to 0, and solve so x equals to negative 5. So negative 5, x cannot be negative 5. That's one of our restrictions. But we have to put it on our number line to test because we need to determine our inequality for this given rational inequality. So from here, we're going to test some values. But before we do that, we need to know that with our negative 5 and 3, anytime we have a restriction, which we have here, we're going to have an open dot on that restriction, our excluded value. From here, negative 3, we're going to have a closed dot. And the reason why we have a closed dot is because of our inequality at the very beginning. So let's start testing some values. So in between negative 3 and negative 5, we have negative 4. So if I test negative 4, I'm going to test negative 4 in our inequality. So it's 8 over negative 4 plus 5. Is this result less than or equal to 4? Well, 8 over negative 4 plus 5 is 8 over 1. And 8 over 1, 8 is not less than or equal to 4. So this is no. So negative 4 does not work. So now we need to test another value. So let's test negative 2. So we're going to plug negative 2 into our inequality. So 8 over negative 2 plus 5. Is that result going to be less than or equal to 4? Well, that'll be 8 over 3. 8/3 is less than or equal to 4. So that checks. And then let's test one more over here, negative 6. So we're going to plug in negative 6 for x. And then obviously that's going to be 8 over negative 1, which is negative 8. Is negative 8 less than or equal to 4? Yes. So that works. We have a yes here and a yes here. So what that means is we're going to be shading going down from negative 5 and going up at negative 3. So this is our number line. So we need to write an inequality based off our number line, which is basically our final answer. So our inequality is going to say parentheses negative infinity to negative 5 parentheses, because we have a open dot, union, which means or, bracket, because we have a closed dot, negative 3 to positive infinity parentheses. So this would be our interval notation. We can also write our final answer as an inequality, which will say x is less than negative 5 or x is greater than or equal to negative 3. So both of these are correct. One is just an interval notation, one is as an inequality. They're the same thing, they mean the same thing, so either way you write it would be correct. Our next example and our last example, we have our inequality to be 10 over x plus 8 is greater than 2. So our LCD is x plus 8. So if I were to multiply this expression by x plus 8, multiply 2 by x plus 8, we know that these x plus 8s are going to cancel. So So I'm left with 10 is greater than 2x plus 16. Subtract 16 on both sides. Negative 6 greater than 2x. Divide by 2. Negative 3 is greater than x. So negative 3 is an x value on our number line. So we have negative 3. And then we're going to find our other point on our number line from our denominator, which is also our restriction, excluded value. So x plus 8 equal to 0, so x equal to negative 8. Okay, so negative 8 is going to go down here on our number line. Okay, so we know that for this inequality to be true, x cannot equal to negative 8 because that negative 8 makes our inequality undefined. So we need to start testing some values. And also to remember that since we have a greater than sign, we're going to have an open dot at negative 3. We'll always have an open dot on our restriction. Okay, and so from here, let's test a value. So we will test, let's see, just say negative 5. So if I test negative 5, I'm going to plug in negative 5 for x. So we have 10 over positive 3 is 10/3 greater than 2. Yes, that is true. So since I know that negative 5 works, that means that anything between negative 8 and also negative 3, it will also work. I could sit there and show you, if I plug in negative 9, let's test negative 9. Plug in that for x. We're going to see that that's going to be 10 over negative 1. So negative 10 is not greater than 2. So we know that negative 9 right here is not going to work. So if negative 9 is not going to work on this side of the number line, then over here at negative 2 is also not going to work. So that's just a way to kind of cut down the work. So we know the solution to this inequality is going to be in between negative 8 and negative 3. So now let's write it as an interval notation or as an inequality. So, interval notation would be pretty easy, which would just be parentheses, negative 8, comma, 2, negative 3. When you're writing your interval notation or your inequality, you must read the graph, your number line from left to right. Okay, and so you can write it this way, or you can write it as an inequality, which would say negative 8 is less than x, is also less than negative 3. Okay, so you can write it either way, and it will be correct.